No recording? Yeah, now it started. Okay, just
At
waiting for
once,
the
eh?
start. Okay, hey everybody. Thanks for joining. Thanks for being here. We start with a little thing about the topic because the topic today is Kubernetes Unleashed for Small.NET teams. I could also call it Kubernetes Unleashed for Small Teams. Uh, yeah, it was just because of the demo is a little bit .NET demo for the focus on the Azure and Microsoft community. First of all, a little few questions. I will paste some statements into the chat, and you give me thumbs up if this applies to you, so I can have a little imagination about how your current state is, where you come from, and so on. First thing is we struggle with deployments. Thumbs up if you guys struggle with deployments. We are using Kubernetes. Second thing, we are using Kubernetes. Thumbs up if you use Kubernetes already. Um, oh, Christian joined. Hi, Christian. Long time no see. Um, and the next thing is, okay, we struggle with deployments. We are using Kubernetes. And the next thing is, if you're already using Kubernetes, Kubernetes was easy to set up. And as I can see from here, come on, Thomas. You have a full cloud access. Kubernetes is easy to set up in the cloud, at least. Exactly. Okay, nobody's struggling with deployments. That's pretty interesting. That's pretty different from what I see outside, but it's cool. Then that means that you're already pretty advanced at this. We are using Kubernetes. 3 of you guys already use Kubernetes. And when I say Kubernetes was easy to set up, is only Julian who's off it. And the rest one is between crying and laughing. Okay, that's pretty reflecting what I often see outside, and what I really often hear is Kubernetes is too big. Kubernetes is like something for big teams. Kubernetes is so hard to maintain. We cannot afford this in a small team, and so on. And to break with this a little bit, we have a session today. As I already said, it was already said, my name is Marius Boden. I'm DevOps Whisperer at Xivia. First thing I always get asked is, what is a DevOps Whisperer? I'm the little voice in the teams who says, focus on your business value, and this can be automated, and yeah, let's do some container stuff. That's why I'm called DevOps Whisperer. What am I doing? My focus is pretty every technology around DevOps. If it's container and Kubernetes, if it's Azure and cloud, if it's infrastructure as code, if it's automation and CI/CD, GitHub, GitLab, you name it. Whenever it comes to these things and you struggle, we should talk. So feel free to connect. And yeah, let's start. What are we going to do today? I will tell a little story around what leads me to doing what I'm doing here and to showing what I'm showing here. A sentence you may already have heard when it comes to DevOps is, you build it, you run it. Sooner or earlier you will hear you build it, you run it, but what does that really mean? You build it, you run it means that teams working in DevOps method with DevOps method and in a DevOps way shall be cross-functional and shall be able to do what's necessary to build, run, and maintain the product. Yeah. If you're the developer, you're not done with developing. You will cover the entire cycle of your application. That also means we give a lot of responsibility to the teams, but we should also make the teams able to fulfill their tasks. And to fulfill their tasks, they need a specific infrastructure. Yeah. If I want to be effective, if I want to be fast, if I want to be explore new things, if I want to try out things, if I want to be the master of my own product and the master of how I run my own product, I need an infrastructure that allows me to do so. And when it comes to this, most of the people end up with a platform. And the state-of-the-art platform here is Kubernetes. And that's why we focus on this today. This presentation is for all the developers, architects, infrastructure teams, engineers, platform teams, whatever, who struggle with their deployments at the time and want to know how to do it easily with Kubernetes. Okay, start with the story where this comes from. Yeah, the role of the developer has significantly changed within the last decades. Back in the days when I started as a developer too, also more than a decade ago. And back in the days, the main focus of the software developer was developing the software. That's why he's called that, yeah? So we needed to know about our programming language. We needed to know about how to compile it, about our IDE and how to set up our IDE. We needed to know a few frameworks. We needed to know about our subversion, our version control system. Oh, I said subversion, yeah. Sorry, but I started with subversion, really. That was pain in the ass. So thank God we have Git now. Yeah, we needed to know about the operating system. We need to know about the hardware below the system. So that's all the things the developer had to know about, and that's already pretty much he had to know about just to build a software or to fulfill a specific part in building the software. But since then, a lot about software and software development changed. We nowadays have more complex scenarios and more complex architectures like distributed systems, new architectures like microservices and something like that. So also the role of the developer had to change to cover the new tasks that came with that. Yeah. So the developer was now a full stack developer, meaning he's not only responsible for, I don't know, a part of the code and writing this part of the code or a module or whatever. Developers more and more become the ones that take care of the front end, of the back end, also data and identity and access management, and so on and so on. So the full stack developer is now capable of doing more by the price of needing to know more and being familiar with more technology. And if this wasn't already enough, people like me can now come to you and tell there's even more you have to know. It's not enough to know front-end and back-end development. Now you shall build it and run it. So you shall know about the whole life cycle. Yeah. The developer in the early days, they did more or less this. Then the part with automation started to grow. So the developers more and more got also into testing. Yes, the good developers did that before. But I've seen a lot of things different. So most of the developers are concerned about that. The better ones are already releasing their software. The even better ones are already deploying their software. But at least when it comes to operating and monitoring, most of the developers quit. So that's a thing we cannot afford anymore because we want to have cross-functional teams that are capable of managing their whole application and capable of managing everything that comes with the application. So we need to enable the people in a specific way to take care of new topics like release management, configuration management, maintenance, infrastructure, security, and so on and so on. So the problem what comes with this is that in the existing teams, there are pretty much undefined roles for the new topics and a lack of knowledge and skills. So that means we need to find a way to distribute the new knowledge over the team and distribute also the responsibilities over the new team. And with distributing knowledge, we also reduce the fear of making mistakes and, I don't know, doing stuff that can't be reverted and whatever. So because we want to enable teams to be innovative. We want to enable teams to try new things. And in order to try new things, we need to, on the one hand, enable them to give them a platform where they can do the new things. And on the other hand, to make it easy to revert changes, to make them, yeah, to allow them errors, yeah, to allow them to do mistakes and revert them and whatever. And that is quite a lot we pack on the back of the developers on top. And that's stressing a lot of developers. And that's maybe also the reason why a lot of teams are not familiar with a lot with those technologies, and why we have like the sayings like Kubernetes is too big and we can't do that, and we don't do that, and it's not the thing for us, and so on and so on. Kubernetes is now the industry standard to run applications. So we don't have to think that we can afford another 10 years without switching to technologies like that. The thing is, how can we make it less stressful for the developers so not every developer becomes a John like him? Okay, but what's the problem actually? What is the problem by just doing the switch and working with new technologies like that? The problem is, and I think that has a lot to do with the lack of knowledge or the lack of experience with the new technologies, is that development teams are forced to do things in a new way, but not taught how to utilize new tools. So what I see often at customer sites is that they try to be, I don't know, we do continuous deployment, but we still do it by shipping an application to our IIS on a Windows server. And we had our configuration in a text file, but this single library requires JSON, and this library requires YAML. So our configuration is a mixture of all of that. And team member one is pretty good in PowerShell, so we have a lot of PowerShell scripts, but also nowadays you do a lot of stuff in Python. So we started doing stuff in Python, so you also mixed that. We have a lot of teams still running stuff on virtual machines, still doing remote execution, or even manual click ops, like, okay, click, 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 now it's working. Oh, I need to go to the machine and do that, and then it's working, yeah? That's not what we're gonna do in the future, and that's definitely not what will let you survive in your business in the next 10 years, because this is way too slow, way too ineffective. And yeah, then the teams come to the also to the parts I told you before, like monitoring. And yes, we have a Nagios already running. Why shouldn't we use different? Yeah, because Nagios comes from a very statical world, from a world where infrastructure was pretty static. And nowadays, infrastructure is way more dynamic. Yeah, we spin up a database here and then it's gone. We spin up a test environment here, then it's gone. Something like that. That's not what you can monitor pretty good with tools like Nagios or Cacti, like in the past. So we need to find a way to get rid of this whole mixture of technologies and reduce it to a simple stack that we all can utilize. And what I can offer here is that. This is a little thing I just made up for this presentation, but it's a pretty nice stack to start with. The whole automation is dependent on GitHub. The system needs to be a Linux with Ubuntu. I'm sad to say that in an Azure Meetup group, but DevOps runs on Linux. So you have to get familiar with Linux somehow. We provision our systems with Ansible. We have all our configuration in YAML files, and we run our application in Kubernetes while we utilize Docker and Helm for deployments. And we monitor using Prometheus and Grafana. And now you would say, okay, these are a lot of tools to learn. And yes, this is pretty much new knowledge. How could we do that? Yes, that's the trade-off at this point. At this point, the trade-off is, okay, you have to do a little Linux stuff, and yes, you have to learn a few new tools. But what is the price you get for this? The price you will get for this is a way to run and deploy your applications in the same way. So you have the one size fits all. If you make this stack work, you can deploy every of your applications to the stack and treat them all the same. So you build the same way, you deploy the same way, you monitor the same way, and you update the same way, you revert and roll back the same way. This is all included in this small stack already. And now I already hear the voices like, oh, we have special requirements. That's why we couldn't change. We have so special requirements. Of course, a lot of customers do have special requirements. And of course, not every application and every business is the same. But the thing is, if you utilize Kubernetes, you get the entry to like the largest ecosystem of all. Like if you make it to Kubernetes, nearly all of your special requirements can be satisfied with tools, processes, and inventions that have already taken place in Kubernetes. So feel free to expand this stack, but maybe start with this stack to get a feeling for what's happening. And these are the phases I mostly see when I explain this. How does it work? How does it go? Can't be serious. Everybody told me Kubernetes is so hard. Yes, maybe that's been in the past. Like my first Kubernetes I spawned up was really vanilla Kubernetes, really from the scratch, vanilla Kubernetes. We set up from the network drivers up to the storage drivers. We set everything from scratch, and yes, that was hard. And that was nothing I would suggest to any small team. But since then, a little time has passed, and Canonical really got something for us. Maybe a little story about that. In our company, we have something that's called Innovation Day. And on Innovation Days, we all come together, focus on specific topics to gain new knowledge, to get a hands-on with the new technology, or just to solve questions we all have in common. So last year, we had an Innovation Day where for example, Stefan and Julian came together with me and we explored lightweight Kubernetes distributions because I had a question, is it really that hard nowadays or is there something that makes it easier for us to start with? And the thing we came up with in the end was micro-K8s. Micro-K8s is from Canonical and they describe it as a zero-ops Kubernetes. Don't believe that, there is no such thing than like a zero-ops Kubernetes. What it really is low ops. And that's exactly the thing where dev teams should start with. Start small. Start with the least thing you need and grow later. So Canonical provides us here with a Kubernetes distribution that can be set up in 18 lines of code. And that's pretty high. That's pretty hot. And the cool thing on top is it has a very small footprint. So if you already have, so the idea is to utilize virtual machines you already have, or virtual machines you can easily spin up. Meaning all of us have this use case where we need to run a Kubernetes on-premise in our data center or something. So exactly that is the use case for this. So you utilize an existing Ubuntu virtual machine and you're able to spin up your Kubernetes in 18 lines of code. And the cool thing about that is you can really start small and scale later because micro-K8s enable scaling by adding new nodes to the cluster, expanding your cluster. So start with a single application there and later migrate more and more applications. And the moment your machine is not enough anymore, you can add more and more machines to your cluster by not changing anything for the teams utilizing the cluster. They still deploy to the cluster if it was the same with one machine. It's totally transparent for the teams, and that's a pretty cool thing here. And the good thing is that makes micro-K8s totally unique is between all those lightweight Kubernetes distributions like K0 or Kind or you name it, or K3S from SUSE. All those are lightweight Kubernetes distributions that are a good starting point. But the thing that makes micro-K8s really unique is that it's prod ready. Canonical says this one is designed to be used in production. And that is something none of the others can come up with. And they also, I did not try this so far, but they also support high availability scenarios. So even if you have very special requirements where your application has to be up 99.9%, take a little more than these 18 lines of code. Of course, you will have to do, but you can make your cluster high available. And that's the cool thing why I would emphasize the teams to start with that is that you can start with the minimum that you need to do Kubernetes and later go to whatever you want to go to. And that's pretty hot. So what I created here also is a little demo, a demo repository. I think, Thomas, you will share the slides later, right? So everybody can grab the QR codes later and so on. This is a repository I created just to show a specific starting point for you if you're not utilizing Kubernetes right now, or if you want to start with another approach. What am I doing there in this repository? I defined a target state which allows an application team, which would be situated here somewhere, to utilize Kubernetes for their application. What do we need in front is a virtual machine, this orange thing here, and then, and in this case, GitHub, because I just built my solution on GitHub. If you have a GitLab or even a Bitbucket or whatever with a pipeline on top, you can do that as well. I just utilized GitHub because that's my favorite tool for automation. What did I do here? I utilized that to create an infrastructure repository. In this infrastructure repository, I have this Ansible playbook, and I have the option to access my virtual machine. In my case, I'm getting a key from a key vault. I'm getting an SSH key from a key vault and access the virtual machine with this SSH key from the key vault. In your case, it could be anything. Yeah, you could also have an username password authentication workflow here. You could have also your SSH key, but not in a key vault, but in the GitHub secrets directly or whatever. At least you need a way to access your virtual machine. And I utilize the default GitHub action runners, which are just hosted by Microsoft in GitHub. You can also, if you have an on-prem setup where your virtual machine is not accessible from outside, you can also host an actions runner within your infrastructure and utilize your own action runner here. That's not a thing. More important is that you have an infrastructure repo describing how you want to provision your virtual machine. For this, you can take my Ansible playbook as a starting point. This infrastructure repo is read from your runner when you create a workflow. You create a workflow, this workflow is divided into jobs, and the runner gets all the jobs that are tagged for him. So the runner gets the job, gets the secret of this SSH key, and accesses your virtual machine to provision the microcates, which is this blue rectangle here. Okay, now we have set up microcates, and within this microcates, we set up GitHub runners. Why do we do that? To be able to provision stuff into the cluster. Because if we have runners in the cluster, we don't need to take care of credentials and stuff. Yeah. Normally, if you want to access a cluster and provision stuff to a cluster, you always have to have credentials. I could have credentials to get to the machine and then do it from the machine locally. Okay, one thing. I could also have direct access to the cluster, then I need somehow credentials to log into the cluster. Admin credentials is not that good. In this case, you would need to utilize role-based access control to create users and so on and so on. It's not that easy. The easiest way really is to have a GitHub runner in the cluster, give the runner all the permission he needs to have, and let the runner do its magic. And that's a pretty cool approach here. So what am I going to do? I have this infrastructure repo, which is read from the runner. The runner provisions my microcates, and then provisions the runner control, the actions runner controller, and a runner for my infrastructure repo. And from this point on, my infrastructure repo has access to the cluster. And then I can deploy whatever I want to the cluster. In the case of my repo, I'm deploying another runner that is dedicated to another repo, enabling the application team to deploy whatever they want into the cluster, into a different namespace, of course. But they are able now to deploy their application credentialless into Kubernetes. And that's what we want to set up here. And to make it easier to understand, I just want to have a look at my Ansible playbook here. My Ansible playbook is really, I kept it as simple as possible. We are here below 160 lines of code. Less than 160 lines of code to turn your Ubuntu virtual machine into a running Kubernetes cluster with GitHub runners inside. What are we doing here? So the first part of the playbook, I also did not work with like Ansible roles and so on to make it not too complicated. Of course, if you're doing it really sophisticated and you, for example, also have an AWX or Ansible Tower or whatever, of course, you do roles and you do more complex playbooks with roles and so on. I kept it as simple as possible to make it understandable for a presentation. Yeah, feel free to adapt that and make it more sophisticated. What are we doing here in the top is we're using Snap on Ubuntu to install microcades and also Helm and kubectl to, yeah, that's just for me. If I install my Kubernetes on a machine, I always install Helm and kubectl on the same machine to be able to debug locally, if I want to debug locally. You don't need to do that if you want to debug remotely or whatever. That's just for me to make it easier to handle locally. I'm preparing a user that's added to the microcades group. That's pretty similar for the ones that already installed Docker on machines. It's pretty similar, yeah? You install Docker daemon on the machine, and then you need to add your user to the Docker group to be able to communicate with Docker without sudo. It's pretty much the same here. After this, we enable some modules. And this is something that's pretty cool about microcades. Microcades come with a pretty big set of so-called plugins. Plugins are nothing but packed applications. The ones already working with Helm may recognize packed application. Okay, that's something like Helm. Yeah, it's pretty much the same. They also utilize Helm packages here, Helm charts. But what is it? A module or a plugin in this case is something that allows me for a pre-configured application to be installed into the cluster. Yeah, they already pre-configured them in a way that it works out of the box. And that's pretty hot because with just saying microcades enable observability, we deploy a full logging Loki is not included, but a full monitoring stack into our cluster, meaning that we have a Prometheus, a clustered Prometheus, we have a Grafana, we already have dashboards within Grafana available, and so on, just with a single line of code. And that's pretty hot. And also, what else do I deploy into my cluster? I deploy a core DNS. That's for the for inner cluster DNS. I deploy storage because in Kubernetes, storage is something that can also be added as plugins, as Kubernetes plugins. So there are different drivers, different storage drivers, different storage classes. And if you go deeper into Kubernetes, this is pretty not that easy to configure and pretty not that easy to decide what you want to do. They come with a pre-configured version of host path storage, and host path storage is pretty nice because it gives you an easy point to start with. It just utilizes the storage of the host machine. Yes, if you want to have high availability, if you want to have this really resilient and so on, you should not use the storage of a host machine, of course. But we want to have a simple solution to start with. And that is a pretty good point to start with because it gives you a storage class out of the box configured as a default class, and it enables you to provide storage for your applications just from the host. We deploy a fully configured Nginx ingress controller. We deploy MetalLB to route all the traffic which comes to the machine into our cluster. And this all together is configured and done within these few lines of code. And in the end, we deploy our GitHub runner where we deploy 2 Helm charts. The first Helm chart is the runner controller. This is like the top application for GitHub, which communicates with the GitHub API to configure and to register and unregister runners. Meaning a new runner shall be created. This one goes to GitHub, exchanges a token against the runner token, and uses the runner token to spin up a new runner. And the same, if I scale down my runners, the same thing. It goes to GitHub and deregisters the runners already registered. So this is the main thing around. And then, of course, we configure the runners we want to have. In this case, this is just the single runner for my infrastructure repo. So my infrastructure repo, after provisioning the machine with Ansible, is able to directly work inside my cluster. And that's it. And for you to see that, I'm going to share my screen here. And the repo looks like that. We have a little bit of Terraform code here. Don't get confused with that. That is just for me to set up a virtual machine in Azure because I don't have a data center. If you will have in your enterprise environments, of course, you will have different ways to provision virtual machines in your enterprise environment. That's just for demo purpose, so I have a virtual machine to work with. Never, really never do setting up Kubernetes in Azure like I do now, because if you want to do Kubernetes in Azure, you do not have spin up a virtual machine and install micro-K8s. You start with AKS or something, because that's managed Kubernetes. But if you want to utilize Kubernetes on your own existing virtual machines, that's the way to go. So ignore Terraform here. What's important is Ansible. Ansible is the playbook I taught you about. This playbook is exactly this file, and this file is just a requirement saying, okay, I'm using this role, and I'm using a few collections, and that's it. So also here again, the typical thing when you work in automation, use as much as possible which is already created. Don't create everything yourself. I'm a big fan of open source projects. Of course, you have to review the projects to be aware of security flaws. Of course, maybe you want to mirror projects so no one can manipulate the code you want to execute. Okay, but utilize the stuff that's already invented by other people than starting from scratch. So I utilize a few rows and collections in Ansible here. And then this is the micro-K8s playbook I already showed you. Yeah, we see here micro-K8s Helm Kubernetes and so on. We see here the micro-K8s modules I want to enable. And we see here the runner deployment. So that's pretty much my whole playbook, 159 lines of code. And I also created some workflows. I created a deploy workflow here. Have a look at that later. It's not that important that I go too much into detail here. What's important is more to see it working. My workflow looks like that. First, I deploy my virtual machine. You don't need to do that. I hope you already have a way. You have a virtual machine, or if you don't have, don't deploy it in Azure. Find a way to utilize, for example, Terraform with your HCI infrastructure, whatever. Yeah, I'm deploying a virtual machine. Now I got a virtual machine, and hopefully I got an SSH key to access my virtual machine. That's what's coming from this part. This is the more important part, provisioning. I'm doing here just the Azure login to log into Azure and get the keys from my key vault. I write the keys into files that I can use with Ansible, and then I run my Ansible playbook. And that's just Ansible playbook with some extra vars, meaningly some secrets I wrote into extra vars, which I also got from the key vault. I have the key file, which I created when I got the SSH key. I have an inventory file, which I also created from variables, which I have in my GitHub environment. And I have an Ansible playbook. Where's my Ansible playbook here? There's my Ansible playbook, microcates YAML. And then I run my Ansible playbook against my machine, and I have a machine that's fully provisioned with a cluster and a GitHub runner inside. And after that, I wait a little. I have a wait timer here because when the cluster is set up, a lot of the deployments say, okay, deployment was successful, but depending on the machine, I took a very small machine here to save costs. It's just a demo. It may take a few minutes for all the components to spin up properly, especially the GitHub runners and so on. So give it a little time to spin up, have a little wait timer here, or make your next step, I don't know, make it with retries or whatever. And my next step here is a test. This test is just saying, okay, I'm setting up a container. And this one is, yeah, this one is already running inside my cluster. So I have now a job inside my cluster. What's happening here is that the GitHub controller creates my runner. The runner sees, okay, the pipeline has a job with my tag. So I need to execute it, and he gets the job, and he creates a container and attaches to the container, and then he does all the work within the container. To see that, we can say, okay, let's see the host name. Yeah, the host name is the same because that's how pods are named in Kubernetes. They usually named whatever name I gave deployment and some whatever things on top to make it, yeah, a little bit more random. We can see that I'm running an Alpine Linux here. That was the container I decided to use. We can have a look at the pipeline for that. So we can see here. Yeah, make the test workflow. Okay, have a look at the test workflow. Let me check that. This is the test which runs. Exactly. I have a test which runs on K8s for small teams. This is the tag of my runner scale set. K8s for small teams. And if this runner scale set, if I meet the tag of my runner scale set, the runner scale set will provide runners which are capable of running my jobs. I'm telling him, okay, make it to run within Alpine and do this, 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 and so on. And we can see in the pipeline that we, for example, yeah, we had the host name, we had the Alpine Linux. And if I now install kubectl, yes, we installed kubectl, and then I can just say kubectl get all, get config maps, get secrets, get ingress in all namespaces, and we can see we can access our cluster from inside. And now we're able to do whatever we want with our cluster. And what am I doing? In the end, I'm deploying some initial resources. What am I deploying? Exactly, the runner for my application repo. That is, in my case, configured on a different place because I wanted just to decouple that of provisioning my machine and provisioning whatever I need to do with the machine. I just want to decouple both of them. If you don't have, if you want to couple those, or if you can couple those, just feel free to do all this in Ansible at the first place. Doesn't make any difference. And with this given, we can see I have an application runner, and the application runner shall be named K8s for small team application runner. And if I now go to my application repo and check my runners, oh, the name's not the same. K8s deploy. Why is it K8s deploy? Can I see it somewhere here? No, that's just the name of the release I'm deploying. That's the Helm release I'm deploying, but the Helm release, I guess it's in the code somewhere. Let me check that. Helm runner. There it is. Runner scale set name K8s deploy. So whoever already have worked with Helm, Helm is like a template engine for YAML deployments. So what can I do? I can create Helm charts, which are like default configured ways of deploying an application. And then I can override these values with the values I want to have. I overrode the runner scale set name with Kate's deploy. And see, my scale set in my application repo is named Kate's deploy. Okay. Any questions about that? By the way, I forgot in the beginning, you can just interrupt me at any place in the flow. So just feel free to talk to me whenever something's too fast, to whatever, to unclear. I know I'm not the best at speaking slow. I know this is pretty much that comes to the ones who haven't worked with Kubernetes yet. So feel free to ask. That's why we're here.
Marius, we had a question from Muhammad. He was asking, do you need a real virtual machine or can you do this stuff in WSL?
You can do it in the subsystem for Linux if you have subsystem for Linux version 2, because subsystem for Linux version 1 does not have a real kernel, so you're not able to do containers inside, and you need to have a container engine. So version 2 is capable, and you would be able to do. And if you want to have this as a try on your Windows subsystem for Linux, just feel free. Docker Desktop, for example, does exactly the same. Docker Desktop creates a Windows subsystem for Linux, and inside this, it runs the Docker daemon, and you can also spin up Kubernetes clusters inside. But it's managed through Docker Desktop, so wouldn't rely on that too much, so better go with this. But it's possible, yeah. So yeah, if you're running on an HCI stack, be aware that you have to enable nested virtualization before, because otherwise the subsystem for Linux will only work in version 1. Because you cannot run a real Linux kernel on Windows. You have to do virtualization for this. And to do virtualization inside virtualization, you have to enable nested virtualization. Muhammad, I hope this answered your question. If not, feel free to ask or write it in the chat. Thanks. You're welcome. Okay, now we have spin up a cluster. Yeah, we can tap ourselves at the shoulder. At this point, we have a cluster. Wow, cool, but we do not spin up clusters just to have a cluster, right? We want to do something with the cluster. So last part of all of that is you have to utilize your cluster in the right way, because you want to have an application inside your cluster. And to make your application working inside a cluster, you make your application ready to do so. For Kubernetes beginners, this means prepare your application and your repository, ensure it's ready for deployment. I divided that into 5 small steps you have to think of in advance. First thing is you have to think about your application. Is your application ready to run inside a container? That can mean a lot of stuff. For the ones that did never run an application inside a container, I would suggest you have a look at 12-factor apps, because they are originally were designed for web applications and so on, and for cloud native applications and so on and so on. But the thing is, they have pretty much thought about a lot of stuff that's necessary when you run an application inside a container as well. So for example, you need to have a way to configure it from outside, ideally through env variables and not a config file. You have to make sure your application can be started, stopped. You can make sure your application has readiness and liveness and so on and so on. So if you want to have a starting point, check the 12-factor apps. And if you can make a check at everything there, you can be sure you will run on Kubernetes. If you cannot make a check on everything, don't be mad. Not all of them are necessary, but it's a good starting point. So make your application ready. That also means think of what your application needs. For example, I had applications, they wanted to run their applications in a container, but they needed a user interface to enter their license. You're in a container, you don't have a user interface anymore. You have you cannot do that. So find a way to make your application run from the console, from the terminal, and find a way to configure your application with less effort, with no manual steps. You can also containerize applications and still make them not work on Kubernetes. Very good example is how they call the ones behind Bitbucket and Jira. Atlassian. Atlassian have created containers to spin up Jira and Confluence and something in Kubernetes. But they totally, I don't know if they fixed it now. It was the last time I tried it was 2 years ago. And they totally messed up with the setup. So yes, we had a container. And yes, we could deploy the container to Kubernetes. But in order to make it work, in order to make the initial process of setting everything up, probably we needed to deploy it as a single instance and scale up later. That's just not working with automation. We cannot just always scale down to a single instance, do stuff, and then scale up again. That's not working. So they try to do this stuff, but they did all just half the way. So what I wanted to say, think of what you really want to do, how you really want to do, and make your application ready. Second thing that's important is automation. Part of the title today was small teams. And we already saw what comes now in technologies and also in tasks on top for the teams. In order to make a small team still be able to handle that, we need to automate as much as possible to get them free to do other things. Yeah. So start with automation. Also, things in a distributed environment and with Kubernetes can get really complicated if you do it wrong. So keep it simple. And whenever it gets a little more complicated, you need resources for that. So make resources free by automating stuff that's normally done by your people. And that can be automated. And after that, you have to take care of releases because I want to know what's running out there. Colleague of mine a few years ago called that fleet management. You need to know what's running out there. And in order to need to know what's running out there, my container cannot be my application latest. If my application latest runs, I don't know which latest is meant. So make a real proper release management to know what exactly is deployed and to make it reproducible. Take care of release management. Then, of course, Kubernetes without containers not okay. It's coming, but it's not here at the moment. So think of how to containerize your application, and in the end, you're ready to deploy, and also that has to be taken care of. And to be able to show you that, I have another repo. It's a little .NET sample application, and I'm going to show you now this sample application. And that is exactly the demo that hasn't worked last time, so pray today. Okay, my sample application. We start at the point where we only have this application. Okay, now we have just an application. It's just, if we go here, it's just taken from the Microsoft samples. It's an Orleans application, Microsoft Orleans. And yeah, it's just an application that's for voting. For example, now I need to get rid of this Teams thing. Okay, I already deployed it, so you can see it. The application looks like that. It says hello world, and then I have here the option to create a poll. I can also, for this demo now, create a poll. Now we can say, yeah, I like green and the others like whatever, and so on. We have just a web application here. Yeah. Okay. So that is our starting point. First check. I took this from Microsoft sample, so yes, it was already ready to be containerized. I did not have to change architecture and so on. So in our mind, we make a check at the first thing, our application is ready. What was the next thing we had to take care of? The next thing was automation. So I created a release workflow. just GitHub workflow saying, okay, I want to do some linting. So every time a developer checks in new code, the code is linted and the pipeline says, okay, code's okay or not okay, right? And we want to do a build and a test. We want to build and test our application. Lint, build, test. Pretty much the basic CI workflow. And after that, so I don't go into detail. You can go and visit the repository later. So that's pretty much what our pipeline does here. Lint, test, build. Okay. So what else? After automation, we needed to take care of releasing. So I extended my workflow. It's still lint, it's still build. And now I have a release job. Release. I'm a big fan of semantic release. There are a lot of releasing tools and a lot of release helpers. If you haven't made a choice yet, have a look at semantic release first. I can just give you this hint. Will save you a lot of work and will save you a lot of pain. But of course, this could be any release tool that suits your needs. Semantic release, when we build our workflow, we upload an artifact. So after our CI workflow, we have an artifact. We have an artifact of our application, of our built and packed and released application. Not released, but published. Excuse me. So a published application, packed, that's it. So our release workflow will download this artifact, zip it, and then we get a key from a GitHub app. So we all do the releases in the name of a system user, and GitHub system users are called apps. So we have a GitHub app that creates our semantic release, and then we let semantic release do its magic. We have a little release config here that says, okay, analyze my commits if they are semantic commit format. Create release notes, create a changelog file, create, and then use Git to check in my changelog file into a new commit and push the new tag and so on, and then create a GitHub release. What's the difference? GitHub release, we can have a look at a GitHub release. GitHub release looks like that. Yeah, it's like, this is my release. It creates a tag with the release. The tag is 1000. And what semantic release does here is analyzing my commit messages. And whenever it finds fix, it will increase the fix version. Whenever it finds feed, it will increase the minor version. And whenever it finds something like breaking change, it will increase the major version. And so I'm totally automated generating my release version. I'm totally automated tagging my repository. I totally automated creating GitHub releases, packing my application and checking it in with the release. So here I can not only download the source code, I can also download my packed application here. Okie doke. That's what we did with semantic release. So now I have releases and I have a packed application, but that's not helping me because I cannot download this packed application and install it to Kubernetes. What do I have to do now is containerize. So next tag is here. Now I extended the whole repository for a Docker file. Yeah, we just use .NET SDK 7 as a build. We do multi-stage builds. We do publishing here, and then we have the final image where we just get the published application, run the application, have an entry point, have a command, and so on and so on. We have a Docker file that's building a Docker, that's describing our Docker image, and we have a new workflow that's called deploy. Why is it not called Docker build? Because I already knew where I want to go to. If I did not knew that at this point, I would call it Docker build or whatever, but I knew I later want to deploy it as well. So I created a new workflow that's working, that's always triggered whenever a release comes in. So the first workflow, remember, did the linting, the build, the test, the packaging, the release, and then it created the GitHub release. Creating the GitHub release, if that succeeds, this one will be triggered and my Docker job can run and build a Docker image depending on the version in the release tag. So the release tag was 100. So my image will be tagged 100. And the last thing that came after building was deployment of my application. And so I extended my deploy workflow to not only build the Docker image but also deploy it. Yeah. So we utilize Helm again. We install Helm at the repo, and then we utilize Helm again to deploy my application. We have a little Helm config here again, also a YAML. I told you I really am a big fan of standards, so all our deployments are done with Helm. All our file formats are YAML, and that's it. So here we describe how our application should look like. We want to have a service. We want to have ingress. We want to have ingress on port 80. So yes, I'm doing HTTP to the web. Don't do that. It's a demo. And in the end, I have a deployment. I have a release workflow that looks like that. And I have a deploy workflow that looks like that. So I can now have a look with you at the release workflow. The release workflow looks like that. We lint, we build, we test, and if both are successful, we release. Why can I trigger release now? Because semantic release is intelligent enough to see, okay, we already tagged the repository at this point with a version tag. No new commits have come on top. So yes, I'm doing my job, but I'm not creating new release. That's what's happening here. And the deployment is building my Docker image and then deploying my Docker image. As I showed you before, yes, my Docker image is already deployed, but I just wanted to show you the brute flows in action. So Docker did the job. Yeah, here are some detailed Docker build summaries. Yeah, we have build inputs, and we can see which tags were created, and so on and so on. And in the end, we deploy to the environment. And the cool thing is, this can only be done because of the infrastructure repo before. You remember we created a runner for this repo within the cluster. And exactly this runner is now deploying my application to the cluster. And that's how easy you can deploy your application there. And to get a feeling why this is cool for small teams, I can show you now how easy it is for someone in a small team to deploy a new feature. So my new feature, I already checked it in a demo branch. We can have a look at this. Before, our application was saying hello world, but today we did not invite the whole world. We are just the Azure Meetup group. So my application now shall say hello Azure Meetup. Now I create a pull request on this. I have my pipeline, which has some jobs. All those jobs are required jobs for my pull request. So I say, if all of those jobs, I have proper testing, I have proper linting, whatever. If all of those jobs are successful, you can automatically merge. I did the review, for example, to say, yeah, okay, yes, my review, I cannot self-approve. Okay, normally you would say approve, yes, 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 fine, my review is done. Okay, this can be done. And you say, okay, auto merge, yes. And the only thing we have to do now is to watch the pipelines go, because now this pipeline will do the linting, will do the build, test, publish, and will do, because we are in a branch, it does the release in a dry mode. So it tries just to do everything it needs to do for a release, but it does not really create a release. And if all those jobs are green, we will have an automatic merge. We will have the same pipeline again in the main branch with a real release on top. And then we will see the pipeline building the Docker image, doing the deployment spins up. So everything the developer has to do when it comes to this point is to develop. And that's the cool thing. We do in DevOps, but still have a focus on dev here, because we come from dev and we are dev teams. And we don't want to focus too much on all the other things. We want to understand them, we want to build them, we want to automate them, but then we want to focus on dev again. And that's exactly what we're going to do here. So what we're going to do here, we do the linting. Linting takes a little time. I should have commented this out. because I utilize the superlinter. Whoever of you guys is using GitHub as a workflow engine, have a look at the superlinter. It takes a little time because the image is pretty big, but you get a one-in-all linter for nearly everything you will do. It has Terraform code checking. It also has .NET and Python and whatever, and JSON and YAML and whatever code linting. It also has security linting like checkov and so on. And it does all the linting stuff. It gives you a nice summary when it's done. You will have a little summary here saying, okay, these checks have been good. These checks have been bad. If something happens, I hope I did my job good. And when linting's done, it will create a release here. It will create, because I called it feature. Yeah, my commit is called feature, so I hope it will increase the minor version, not the bug fix version. And let's see when it's done. Is it done? Isn't it done? Isn't done so far. Hope you have a few more minutes time. It shouldn't take more than 4 to 5 minutes for the demo to end, and then you're free to go. Successfully linted, and now shouldn't take too long for our summary here. Also cool for the developers, if you do it right, all the information they need are directly here under the pipeline. So the developer just needs to check in his code, create a pull request, and everything else is on the UI of GitHub. Yeah, you can do the code review here. You can do merging here. You can see what the pipeline does. You get summaries from the pipeline about the Docker builds, about linting, and so on. So that's pretty cool. And the release is done. So hopefully now we have a release here, and I'm getting freaked here. Okay. The release wasn't done because we were still in demo branch. We can't release a branch here. Now the same pipeline is running again for the main branch, and now not in dry run mode. Okay, I showed you the dry run mode now. Now the pipeline's running in the main mode where the real release is done. Of course, you could optimize this a little bit, saying, okay, we don't need to do the linting again because we already linted the branch. But in my experience, it's better to lint on both sides, the branch and the main branch, the feature and the main branch, because merging and how developers merge stuff, if there are conflicts, in my experience, often leads to problems with linting later on. And the thing you don't want to have a green button on the branch, merge it into main, and the next one checking out gets a red button. So why that? So that's not what you want to have. So I'm a friend of linting once more than once less. So again, we're doing the linting stuff. If you have your own runners, implement a good caching strategy, and you want to have to pull all those images again and again. Yeah, if the image is present on the runner, the image will of course be used and not pulled again. GitHub with its runners always spins up like a micro VM. So it feels like a full VM virtual machine. So that's why it's completely clean. That's good for building and that's good for testing and so on. But if it comes to big images, it's not that good because they don't have the best caching algorithms there. But linting shouldn't take too long anymore. And then we will see a release, and hopefully we will also see a new release here in the releases section. At this time, we are only this one release away. After that, we should have another one. Again, we can access our application here, and it says Hello World. Let's see how it looks like after the release of our new cool feature. So where are we at the moment? Successfully, that's good. Yes, linting's done. Yes, okay. Now the release will take place. And that was exactly the point where my last demo broke, so I'm a little bit nervous right now, but looks good. Looks good so far. And also here, found tag 1. Yeah, so found 3 commits since last, and so on. Next version will be 110. So if we now go to the releases section, we have our 110 release with our new application build. And in the actions section, our deployment pipeline should have been run, but I changed something about the deployment before. So the deployment pipeline was run, but this job was skipped. And I know why it was skipped, because I made it work with an input from a manual release, and the input from the manual release, it wasn't available. Thanks for that. Don't make changes right before a demo, but that's not a problem. I made it able to run manual. So what normally would have run is we now would have this pipeline, this 1.0 pipeline, to run on the main branch or exactly on this tag. It will build and push the image, and then of course also deploy this. That is what the pipeline would have done if I wouldn't have messed it up before. So let's do it manually here. Now the Docker job runs to build a Docker image and push the Docker image to the registry. I'm utilizing at this point the registry within GitHub. It was just the easiest point. If you're in an on-prem scenario, think about where you store your images, because your machine with the Kubernetes, with the microK8s Kubernetes, may not have access to wherever you store your image. So be aware that the machine needs access to the image registry. In my case, it runs in Azure and of course has access to github.com. But in your case, it could be different. Or for example, I have a customer who runs in a very restricted environment with a lot of firewalls and a lot of proxies and so on and so on. Keep that in mind. Those will definitely get you some more gray hairs on deployment scenarios. But it's all makeable and all achievable. So we deployed. Deployment's done. And if I now go to my application, it says, bad gateway, thanks for that. It says, it takes a little, hello, AzureMeetup, there it is. And so what I have shown here, that with a little bit of offset of skilling, offset in setting up infrastructure, we can enable a small team to deploy to Kubernetes in an easy way. And that's I think that's a big headline here. Yeah, and on this I can finish my presentation here. So feel free now to ask your questions. If you don't have questions now, but they will definitely come up if you try it out at home, feel free to contact me later. Thank you for your attention.
Hey, Marius. Perfect. Yeah, just in time, would say, because we also overdo it a little bit with our pre-monthly thing. So that was a great session. And if there are people that have, let's say, a few questions, just spin on your mic and just go into discussion with Marius. He will be really glad to answer your questions.
I have a question.
You have a lot of questions. I think. What's it?
How happy or how was the maturity of the Ansible microK8s modules for when you used Ansible? You say okay, and there were a lot of examples, or it was a pain, or you had struggle?
Actually, I did not use any module for that. I just used the Snap module. Module to set up microK8s, and that was, that's a pretty well maintained module. So okay. I think it's also built into Ansible. It's in the community package. So that was easy to use. I did not really research for microK8s modules itself, because I think it's pretty new. So I don't think they're mature enough. So what I did there was to utilize the command module just to say microK8s enable, whatever. Not a best pattern, but it did the job. And in the end, to deploy the initial runner, I used the I use the Helm and Kubernetes modules, and those are pretty good, but have a lot of dependencies that are not that easy to set up. So not that happy with those modules.
Okay.
Because of the dependencies.
Yeah. Need a shit ton of prerequisites set to make it running, right?
Yeah, and exactly, and they for example, they want to have some Python modules installed, and installing Python modules directly on Ubuntu is not that easy anymore because they locked it for the system. You have to. That's why I took the role from Geerling guy. I love this guy. He has so cool roles, and he has created a role which deletes this log file in Ubuntu to make it able to install Python packages system-wide.
Oh, okay. Little hack.
But it does the job like all of his models.
Yeah,
And bro,
it works.
This guy is crazy, like hell.
Any further questions? So if not, I would just turn off the recording. So any last words from you, Marius, to the audience out there, if we stream it or we put it to YouTube or wherever?
Feel free. I'm there for the community.
Perfect last words. Good. So recording is